Okay, so what you've seen so far are some of the inequalities for concentration bounds to just understand how a random variable can be analyzed if you have partial information, essentially partial information about its mean or its variance, or in some cases if you know the random variables are independent and you care about the sample average deviation from the mean. Right. So, where you can use either Markov, Chebyshev or Hofting. So, now what we will see next are some general probability facts which come very handy when you are analyzing probabilistic or randomized algorithms. So, let me put down a few. These are almost some of them are trivial, but still it is good to put them down, right. So, the first thing is what is called as a union bound. Which is an, as I said, an almost trivial fact, right. So, if I have two events A and B, then the probability of A union B I know is the probability of A plus the probability of B minus the probability of A intersection B. Now, when we do analysis of random algorithms, right, so sometimes it might be hard to calculate these probabilities of A intersection B's because of the complicated nature of these events. So, what we will essentially say is that I am just not going to care about this A intersection B. Instead, if I want to understand A union B, I will say that it is at most P of A plus P of B, because this value is anyway greater than or equal to 0, it is a probability, right. So, if these are disjoint events, then it will be 0, otherwise it will have some number between 0 and 1, which means that if I remove that, if I do not consider that, then I am not subtracting out some quantity from P of A plus P of B. So, this will give me an upper bound. This is a trivial fact, right. So, now this also extends to multiple events. If you have multiple events A1, A2 dot 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 AN, then I can use the same union bound to say that this probability is at most sum over I equals 1 to n probability of AI. Again, these are not exact probabilities, this is an upper bound. Often these might be loose, especially if the events that you are considering have a lot of intersection and so on. Nevertheless, this is an upper bound, and sometimes this is the best that we can do when we do analysis, or in sometimes because we do not really know the nature of these intersections, so to say. So, we will just go with union bounds, right. So, it is a simple trivial fact, but then it is a very powerful tool that comes in handy when you are analyzing randomized algorithms. That is one, union bound. So, let me call that 1. The second fact that I want to talk about is even simpler. Let us say you have two events where the event A implies event B, right. So, let us say if A implies B, what does that mean? That means if you think of this as Venn diagram, so this is event A. If event A happens, then event B also happens, right. So, that is what A implies B means, which means should B be a superset of A or should B be a subset of A, right. So, remember, if A happens, then B also should happen. So, where should B be? Pause and think, I will tell you what the answer is now. Okay, so, if this is A, if A happens, then B also has to happen. So, B cannot be inside A. So, B has to be outside A, right. So, B has to be a superset of A. Yeah. So, if now the event A happens, that means that one of these things happen. So, that means that is also part of B. So, B also happens, right. So, A happening implies B also has happened, right. On the other hand, if B happens, which means that I might have one of the events here, then that does not necessarily mean A has happened. So, A implies B means that B is bigger than A, which means that the probability of A is upper bounded by the probability of B, right. So, if A implies B, then if you have two events where A happening implies B also has happened, then the probability of A is at most the probability of B, right. So, so that is another simple fact to keep in mind. Okay, so these are some inequalities and some simple facts that will come in handy when we do randomized algorithm analysis later on.